Welcome to this lesson on plane and diagonal scales. Scales let us represent objects accurately at a full, reduced, or enlarged size. Large objects must be reduced proportionally so that they can be represented accurately and conveniently on a drawing sheet. Very small objects may be enlarged so that their shapes and details can be drawn, studied, and measured clearly. A scale is a graphical drawing aid used to represent actual dimensions at a full, reduced, or enlarged size. A full-size scale represents an object at its actual size. 1 unit on the drawing represents 1 equal unit on the object. A reducing scale represents an object at a smaller size than its actual dimensions. An enlarging scale represents an object at a larger size so that small details can be shown clearly. The ratio of the length drawn to the actual length represented is called the representative fraction, abbreviated RF. The representative fraction is the length drawn divided by the actual length. Both measurements must be in the same unit. If 1 centimeter represents 1 meter, then 1 meter equals 100 centimeters, so the representative fraction is 1 over 100. A plane scale reads a main unit and one smaller subdivision of that unit. The common zero is positioned between the two sections. Main units are read towards the right, while smaller units are read towards the left. A diagonal scale is used when a finer degree of accuracy is required. It can read a main unit, a smaller unit, and a further fraction of the smaller unit. We shall first construct and apply a plane scale before proceeding to the construction of diagonal scales. A plane scale reads a main unit and one smaller subdivision. A diagonal scale adds a second, finer subdivision through diagonal division. Our example: construct a plane scale in which 30 millimeters represents 1 meter, and which can read up to 4 meters. 1 meter equals 1000 millimeters. So the representative fraction is 30 over 1000, which simplifies to 3 over 100. Since 30 millimeters represents 1 meter, for meters needs 30 times 4. The required scale length is 120 millimeters. Draw a horizontal line, A to W, 120 millimeters long, the required length of the scale. From point A, draw an auxiliary line, A to Z, at any convenient acute angle to the baseline. Keeping the same radius, step off for equal divisions along the auxiliary line, and number them 1, 2, 3, and 4. Join the fourth division point to W. This line fixes the direction of the required parallels. Align the long edge of the set square with line 4 to W, and rest a ruler firmly against its shorter edge as a fixed guide. Slide the set square until its edge passes through point 3, and draw a parallel to 4 to W, meeting the baseline at F. Slide the set square to point 2, and draw another parallel, meeting the baseline at E. Finally, slide to point 1, and draw the last parallel, meeting the baseline at T. The baseline is now divided into 4 equal portions. Each portion is 30 millimeters long and represents 1 meter. At each division point, draw a perpendicular 40 millimeters high, and join their upper ends. The height is chosen only for clear presentation and does not affect the measurement. Point T is the common zero. Main units are read from T towards the right, and smaller units from T towards the left. The first portion, A to T, represents 1 meter, or 1000 millimeters. We divide it into 10 equal parts, each representing 100 millimeters. From A, draw another auxiliary line at a convenient angle below the baseline. Keeping the same radius, step off 10 equal divisions along this auxiliary line. Join the 10th division point to T. This sets the direction of the subdivision parallels. Align the set square with the line joining the 10th point to T, and rest the guide ruler against its shorter edge. Slide the set square through the remaining division points, drawing parallels that cut A to T into 10 equal parts. From each subdivision point, draw a perpendicular up to the top boundary of the scale. Beginning at 0 at T, number the smaller units towards the left, in intervals of 100 millimeters, up to 1000. From 0 at T, number the meters towards the right. 0, 1, 2, 3. The first meter lies to the left of 0, so W is not labeled 4. The outer boundary and main divisions are now made heavier. The completed plane scale is 120 millimeters long, reads up to 4 meters, and has a representative fraction of 3/100. We now apply the plane scale. We shall construct a regular pentagon in a circle whose diameter is 2.3 meters, using the general method. 2.3 meters is 2 meters plus 300 millimeters. We measure from the 2 meter mark, across the common zero, to the 300 millimeter mark. This span is 2.3 times 30, that is 69 millimeters. We transfer that exact span to a new position and draw the diameter, A to B, equal to 2.3 meters, 69 millimeters on the drawing. With a radius greater than half of A to B, strike arcs from A and from B, above and below, cutting at U and V. The line through U and V is the perpendicular bisector, giving the center, O. With center O and radius O to A, draw the circle. It passes through A and B, which are the ends of the horizontal diameter. From A, draw an auxiliary line and step off 5 equal parts. Join the 5th point to B. For the general method, we use the second division point. With the set square and guide ruler, draw a parallel to 5 to B through the second point, meeting the diameter at F. With radius equal to the full diameter, strike arcs from A and from B. They intersect above the circle at Z. Draw a line from Z through F, produced to cut the circle at E. The line from A to E is the first side of the required pentagon. With the side A to E as radius, step around the circle to locate the remaining vertices, R, H and X, so the 5 vertices are A, E, H, X and R. Join the vertices in order, R, A, E, H, X and back to R, and outline the completed regular pentagon. Here is the finished regular pentagon, inscribed in a circle whose diameter was obtained directly from the plane scale. We constructed the plane scale, read 2.3 meters from the 2 meter to the 300 millimeter mark, transferred the distance, drew the circle, and applied the general method to construct the regular pentagon. A plane scale provides a main unit and one smaller subdivision. When a finer degree of accuracy is required, a diagonal scale is used. The next lesson will explain and construct diagonal scales.